So let's take a look at what the inverse of a function is. So the first thing you should know about functions and their inverses is that um, a function, let's say x squared, so we have this over here, which is y equals x squared. Its inverse is symmetrical about the line y equals x. Here's a line y equals x, which means if I reflect every piece of this across this line over here, I will find this here. This will be here. So basically what happens is it looks something like this. I've got this over here and this over here. And this is good to know strictly because you can use this to quickly identify graphs that are the inverse of other graphs. So if I told you, for example, here's one graph, and here's um, another graph, and I asked you, are these two graphs inverses? Well, what you would do is take the original graph, try to reflect it about this line over here, and you would see that each of these points reflect here, or each of these points reflect here, and then you could say, yes, they do, they are inverses of each other, because the graph 2 over here is the reflection of graph 1 about the line y equals x. So that's just good to know. But also, algebraically, here's what happens when we inverse a function. So let's take this function here, y equals 3x plus 4. Let's take this and let's find its inverse. So to find its inverse, what you want to do is you want to first replace the x with y and the y with x. So what you're doing is you're just switching the places of x and y. So x gets written where y was, and y gets written where x was. And the reason you're doing this is because we know that so here's my domain set, call it my set x, and here's my range set, just call it my set y, and all the elements from x get sent to y by my function f. But the inverse does the opposite. It takes my set y and sends everything to x, so this is inverse of f. So the inverse function um, does the opposite of my function, and instead of taking points from x and sending it to y, it takes points from y and sends it to x, which is why x and y now are reversed. But we don't leave the function like this. Although this is correct, we don't leave it like this. We now want to isolate y and get a function in standard form, because that's how we understand functions. We understand them in standard form. So let's isolate my y. I get x minus 4 equals 3y, and then I divide both sides by 3, and I get x over 3 minus 4 over 3 equals y. Now, this is done. I don't have anything else to do here. Y is isolated. Y equals x over 3 minus 4 over 3. And since this is the inverse, since this is the function form of this equation over here, I can put a little -1 exponent here to indicate that it's the inverse of my initial equation up here. And we've just solved for the inverse of this linear function. Now, in the next video, you're going to see how to find the inverse of a second degree function.